Let's get started. Today we're going to kind of move into the more typical way that I'm going to be running classes this semester, which is I'm going to typically at the beginning of lecture for about 20 to 30 minutes, I'm going to hit on the high points in the notes, the things that I think maybe you haven't seen before are particularly difficult to understand. You are responsible for everything that's in the notes. For example, I'm not going to go over the random number generation that you see in Dr. Planck's Printf notes today, but you are responsible for that. I just don't think it's very complicated. You saw random numbers in 102. He's using a slightly different set of random number functions, but it's the same idea with using a seed and with using time function to get a unique seed. We covered that in CS 102. I think you should be able to look at those notes and be able to figure out what he's talking about when he goes through random number generation. So I'm not going to cover that, but you're expected to know it, okay? And likewise, if I don't go over stuff that's in his notes, you're still responsible for it, but I just happen to think that that's easier stuff that you should be able to get on your own. Now, you should feel free to ask a question about it. Just because I think it's that way doesn't mean it's so. You should feel free to say, hey, I looked at this, I didn't understand it, could you please go into it? But in general, I'm going to pick a few topics like today. I'm just going to quickly touch on character input. There's something about that I just want to highlight. You went over ASCII codes yesterday in lab, so I'm not going to repeat them today. Those of you who have been in 160 have seen octal and hex, correct? You should have gotten to them even if you're simultaneously taking 160. Is that correct? But those of you who haven't quite seen it, so I'll take just a couple minutes to touch on it, but you're going to have to kind of get it on your own. A couple things about Printf. Then the difference between the error and the output stream, which I don't think you've covered yet in lab, right? You did? Okay, but very good. So I'll say something about it again because I know that's new. And then there's something in Dr. Planck's notes about something evil about vectors, and I'll go over what that evilness is. Okay, so with character input, the thing that you need to just be careful about, and it's not really a problem with the gold lab 0.5, but it did show up in Dr. Planck's notes, actually, but not these Printf notes. So if you are reading single characters, so you declare a char C, and then you're just going through a file like he is here, and you're reading the characters. And here what we're doing is we are counting the number of characters, supposedly counting the number of characters in the entire file. Okay? So he has this file, okay, love me 2 times, baby, love me twice today. Is that a song, lyrics from some song? Because often, what is it from?
It's like The Doors, but I can't remember.
Okay. Dr. Planck's big into lyrics in his notes. So if you see stuff that looks sometimes a little odd, it's probably lyrics from some song he likes. Okay, so he's counting the number of capital L's here. He's also counting the number of characters in the file. And you can see that there's some spaces in this file, right? Well, the thing to know about character I/O is that it doesn't, the greater than operator does not read spaces, okay? It ignores spaces, or it ignores whitespace characters. So whitespace characters include spaces, tab characters, which we represent by \T, that means a tab character, new line characters, which we represent with \N, return characters, which we represent with \R, and form feed characters, which we represent with \F. It won't read them. It will skip over them. So if you are reading a file and you think that you want to read every character, does anyone remember from 102 what that one is? It is get C. You would call get C. Now we're not going to worry about that in this course, but I just wanted you to be aware of that fact that the greater than operator ignores whitespace characters. So in fact, in his example, when you think you've got a count of the number of characters in the file, you have a count of the non-whitespace characters in the file. And there, in fact, is a program called word count, WC in Unix, and you can use it to get the number of lines, the number of characters, and the number of words. So it's saying that input mixed text has 1 line, 10 words, 44 characters. But if you run your program that he wrote, he comes up with only 33 characters. And the reason he came up with only 33 characters is there were 11 whitespace characters in there. So just be aware of that fact. Now that's not going to affect you on the Gold Lab where you're reading characters. But it's just something I want you to be aware of. The second thing is the nature of input and output, which is that it's done, C++ treats input and output as a stream. It doesn't see lines. If you have cat, dog, mouse as your input, that's not the way C++ sees it. It views it as a single continuous line of input. So the way C++ sees it, the C++ view of it, is as cat, dog, and mouse. Now you can force C++ to view it as lines by using what command? GetLine. So it can be forced to, but normally with the greater than operator, it views it as a single long line of text. The implication of that, I think most of you figured this out for the Gold Lab, but the Gold Lab had input, would have dots and some other stuff, but there would also be gold. Okay, and the only things you had to worry about were things that were letters, right? And the input didn't have to always be the same width. And you might have initially wondered how if you should read it as a line, and then somehow after you read it as a line, you should break it into characters. But based on what I just said, you would realize that the line format of input is immaterial to C++, that it actually just views this as ... AB with a space, ... underscore like that, and the space .c. That's the way the input looks to C++. So in fact, you could simply read that gold as though it were a continuous line of input and essentially just write while cin into, I don't know, I'll just call it C. Okay? And it's going to read each of the characters in this file, and because it skips over whitespace, in this case the whitespace is actually new line characters, but it will simply skip over them because they're whitespace. And so you could write the loop very simply as while cin into C. So you're combining two facts there, the fact that it just looks at a file as a single continuous line of text with the fact that it skips over whitespace characters. Okay, and again, it's not, when it looks at it as a continuous line of text, it's not actually a blank line or a blank space where there's a new line character. There's actually a new line character there. It's just an invisible character. Okay. So questions about character input and the notion of things as a stream. Okay? Very good. Okay. The next thing I just wanted to quickly go over is octal and hexadecimal formats. Octal is actually not very common. Hexadecimal is more common. So as you learned in 102, and if you've taken 160, typically computers operate on a base 2 number system. So the way a computer stores information is using bits, which can be either 0 or 1. Sometimes it is useful to talk about two other number systems that are multiples of 2. One is base 8 and is often called octal, and one is base 16 and is called hexadecimal. Okay, so in the octal number system, you have 0, 1, 2, 3, 4, 5, 6, and 7 as your numbers. And at 8, it then becomes 10, 9 is 11, so actually perhaps a better way to do it in octal. We have 0 is 0, 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7, but 8 now looks like 10, so 0 ones plus 1 8. 9 is 11, it's 1 1 plus 1 8. 10 is actually 12, it's 2 1s plus 1 8. Okay, what would 16 be? Not you, because I know you know. Someone else. What is, Jeremy, what is 16 going to be? How many 8s are in 16?
2. So
okay.
18.
Okay, 2 8s, and how many's? Okay, so if you have 2 8s, that gives you 16. So how much is left over for the 1s? So if I had to say it like this, 16 equals 2 times 8 plus what?
Oh, 0.
Times, very good. So it's 0. So in general, what you're doing when you have a base 10 number, you're simply figuring out to get that base 10 number, so we'll have some base 10 number, I'll call it Z, which is in base 10. You figure out, for example, it has how many, say, 8 to the second plus, we'll say x1 plus x2 times 8 to the 1 plus x3 time, whoops, still bad, there we go, x3 times, say, 8 to the 0. In that case, it would look like x1, x2, x3. So basically, what you're doing is you're figuring out powers of 8, and that's what each position represents. So here, that's the number, that's essentially 8 to the 0, the number of 8 to the 0s. That's the number of 8 to the 1s. That's the number of 8 to the 8 squares, and so on. So that's how you do your counting in octal. You've already seen one example of using octal in this course. Okay. Does anyone remember what that was? When did you use octal, Mark? chmod. So when you were setting up your directories, okay, you used it. And it was the read bit, the write bit, and the execute bit. Okay? So the read bit might be 1 to say the file was readable. The write bit might be 0 to say that it's not writable, and the execute bit might be 1 to say it's executable. And the way that you could write that is as 5, because this is the 0th position, so we had that's not quite octal the way I want it to be. Great. This is still actually in base 2. Is that the numbers themselves kind of represent 3 bits. So they're represented as octal. Okay, so you had the individual numbers were constructed using base 2. So this was 2 to the 0, this was 2 to the 1, and this was 2 squared. So it was 4 plus 0 plus 1 gets you 5. But then the 3 numbers, there were 3 permissions. 1 for the world, 1 for the group, and 1 for yourself, your personal permissions. And each of those was represented using 3 bits. So you might have, for example, 7, 5, 5, which would mean personal you had read, write, execute, but group permissions were read and execute, and your personal permissions were read and execute, and you would write it as 755. This is as octal. Okay, 3 bits are required to represent an octal number. Okay, because 3 bits can represent the numbers 0 to 7. Okay, now we don't use octal very often, so beyond this, the only time I've really used it is with ChangeMod. But hexadecimal is a different beast. Okay, you're going to use hexadecimal, which is base 16, a fair amount in this course. So hexadecimal starts also counting 0, 5, 6, 7, 8, 9, and then it goes A, B, C, D, E. And that stands for 10, 11, I missed the F, 12, 13, 14, and 15. So you will see that an A, B, C, D, E, F represents 10 through 15. Okay? So now, if you have, say, 20 in base 10, that is equal to 1 times 16 to the first plus 4 times 16 to the 0. So in base 16, it is 14. Okay, if I have, I'll make it 30 in base 10. That's 1 times 16 to the first plus 14 times 16 to the 0, which makes it equal to 1e in base 16. Okay? So you're going to have to get somewhat comfortable with thinking about hexadecimal in this course. The reason is that you may remember computers are often based on bytes. Is anyone, let's see, actually I'll start calling randomly on people. So Matthew Boxstein, you here? Matthew, how many bits are in a byte? Remember? 8. Very good. So what's nifty about hexadecimal is that it takes 4 bits to represent a hexadecimal number. So if you think about it, 111 in base 2 is equal to, that's 8, I'm sorry, yes, that's 8. This one is 4, this one is 2 and 1. So 8 plus 4 plus 2 plus 1 is 15, which is the biggest number you can get before flipping over to 10. So you can represent a hexadecimal number with 4 bits. Well, that's convenient. We have that a byte is equal to 8 bits. And it's rather inconvenient. If I have a byte that looks like that, it's rather inconvenient to have to write it out completely. So instead, we often write it out as a hexadecimal number, as 2. So the top half, let's see, we'll have Brandon Barker. Are you here? Brandon, tell me what this number is just in base 10. That's base 2. So this is base 2 right here. Okay, so you have to figure out how to convert it to base 10. Go, next to you. Think out loud, because you're kind of, I can see you doing it. How many, what does this mean? Okay, this is good. 8 plus, you had it, plus 2. So this one represents 8, that's 2 to the third. This one represents 2 to the second, but it's a 0. This one represents 2 to the first. And this one represents 2 to the 0. So it's 8 plus 0 plus 2 plus 0 is 10. Okay? So that gives us Daniel Barry. Daniel or no, just like Daniel. So what does that give me for hexadecimal? What is that 10 in hexadecimal? A. Very good. So the first digit in hexadecimal is A. Okay. And let's see. Ganesh. Is Ganesh here today? Ganesh. Tell me what the second one in base 10 is. If I convert the second set of 4 bits to base 10. No? You can discuss it with a friend. So what would the, so how, okay. Got a confab back there? Nope.
We got 14.
14. Okay, so how'd you get that? You're right. 2 to the third, so this first bit is 2 to the third, plus that bit is 2 to the second, plus this bit is 2 to the first, and then this is 0 times 2 to the 0. So that gives me 8 plus 4 plus 2 is 14. Okay? And just, you're looking like you're raring to go. What is that in hexadecimal? E. So in hexadecimal, we would represent the contents of that byte as AE. And that's a much more compact way of writing it. Now, in a couple weeks, we're going to get to pointer addresses, or pointers, which are memory addresses. And memory addresses are either 4 bytes or 8 bytes, depending on your processor. And it's much, if you had to write out 32 bits, that would be very time consuming. But if you only have to write out 8 numbers, which is how many hexadecimal numbers are required to represent a 32-bit quantity, that's much more compact. And so you'll see that when we get to talking about memory addresses, which you will see a lot of in your computer science careers, it's a lot easier and more compact if we talk about those memory addresses using hexadecimal format. So you need to get comfortable using hexadecimal format. Okay, if you haven't had 160, you're going to have to probably practice up a little bit on that. So you may have to go to the internet or something, but you should get a little practice. Make sure that you're comfortable converting numbers that are in hexadecimal to base 10, converting numbers that are in base 10 to hexadecimal and the like. I'm not so concerned about octal. You'll get that in 160. So, questions? Actually, you had.
You answered it.
Okay. Yes.
Is it reasonable to think like, so say the number 1110,
Mm-hmm.
to think like 0, 1s, 1, 2, 1, 4, 1, 8?
Very reasonable to think about it that way. Very reasonable. So if that's the way you think about it, perfect. Okay. Other questions? Yes.
What does the 0x that usually comes before hexadecimal?
Okay, so the question is, why does the 0x usually come before hexadecimal? So usually I don't write AE. Usually you see it written 0xAE. The reason is on output. If I just say AE, you're reasonable if you think it's a string, right? So to make it clear that this is a number rather than just a string, we put 0x in front of it. And in particular, to make it clear that is a hexadecimal number. There's also, if I just wrote, say, 173, naturally you would think that's base 10, right? But by putting 0x in front of it, now it makes it clear we're talking about it's a hexadecimal number. So basically, the 0x is a idiom for kind of an alert saying, hey, don't think of this the way you normally would interpret this string. It actually is a hexadecimal number. The same thing with octal. Octal starts with 0. So if you see 013, it actually is saying that's octal, okay, rather than hexadecimal, or rather than base 10.
Okay.
So it's just kind of thing, saying that's what this is. Other questions? Okay. So, moving on, you have printed, formatted output, and cout is what you have been using to date. It is somewhat clunky when you want to do formatted output. Okay, so let's say that I wanted to print a number in a field 6 characters wide with 2 decimals or 2 digits after the decimal point. And I wanted to do it using cout. You learned how to do this in 102. So we'll see if you remember. So do we have Jose Marco Rico in here? Jose. So can you remember, I know, just all you have to do is remember one of the I/O manipulators here. You don't remember any? That's okay. It's okay. That's why we're doing this review. So, Michael Price. Michael, do you remember?
For the first one, would you do set W6?
Very good. Set W6. Care to do any more, or do you want me to move on? Move on, okay? Let's see. How about Paul Proctor? Paul.
Set precision 2.
Very good. Set precision 2. Okay, is there anything else? I'll throw this open to the peanut gallery, yes. Very good. We have to put fixed in there because if I don't put in fixed, what's going to happen? Anyone remember? It's going to print it in scientific notation by default, and instead of it printing 2 digits after the decimal point, it will print 2 digits total. So if I had a number that was, say, 85.312, instead of it printing 85.31, it would print 85 exponent actually I believe 0 here. So it would be just printing the first 2 digits. So you also have to put fixed.
But we have to put fix and show point before set position.
It's a good, I don't think it matters, no. As long as, I would have to test that, but I don't think so. I hesitated for a moment too, but I believe that as long as you have not yet printed, it doesn't matter, because it's simply setting flags. So in CIN or COUT, it just has a set of flags that says whether you're printing in fixed or scientific notation. So I believe as long as you do not actually have a number printed before that, it should work. Okay, you can try it and check it, but I'm pretty sure it works. Actually, Alan, can you take a moment and do that? Make sure that that's true. So this is how you would do it if you were in, using COUT. And it's rather verbose. Can we agree it's rather verbose? Just for one number. So Printf is a C statement that has also been adopted in C++. And quite frankly, it allows you to express your printing or formatting conventions or specifications in a much more compact way. So with printf, we would write the same thing as percent 6.2f, and that doesn't stand for fixed. That stands for print a floating point number, x. Okay, so I think we can agree that the second one is much more compact than the first one, right? So printf is what, if you really want to use cout in this course, you can later in the course. Early on, when we tell you to use printf, we want you to use printf. But what printf is it is you start with printf, it's a function call. Then in parentheses is what we call the format string. So it specifies the format of the output. And then you have an arbitrary list of variables that you want to print. And the format string describes how these variables should be printed. So a format starts with, if a formatting command starts with % sign, that says a formatting command is about to follow. Okay, there are a number of things that can go here. Okay, the first thing, if you see it, may be a minus sign. Someone who read the notes, what does that minus sign indicate?
Justify left.
It says left justify. So by default, you may remember from 102, left and right were the I/O manipulators to left and right justify. Okay? Here, with printf, if you want to left justify, you say minus. By default, you right justify. If you don't say anything, it's right justified. Yes, Alan?
So fixed afterward does seem fine, said. But I just thought I would mention that without fixed, it doesn't necessarily mean scientific notation. It will print it, I don't know what the range is, but for some range of small numbers, it will just print it normally. Like
It will print. Okay. Okay. I can tell you what. Thank you. So it doesn't. Okay. So it uses scientific notation when it's about to lose precision. So with 85, it didn't have to lose precision. It doesn't worry about anything to the right of the decimal point. But if you have if I had instead, it had been 853, now it would have gone to scientific notation, I believe, because it would have printed it now, I believe, as 85. And I have to admit, I'm always a little weak with, I'm not sure if this would have been Try printing 853.
800, I just did 858, and that it printed it out.
Even with precision of 2?
Yeah. It just printed it.
In a field of width 6. Weird. That's, okay. I'm going to have to look, that's not doing what the command is specifying. It really should be stopping it at 2, and it should be truncating the 3 and saying something like maybe exponent 03 to indicate.
If I do, like I did 858 just by itself with step precision 2,
Mm-hmm.
printed 858. Then I did 858's point and then just a bunch of numbers after the decimal. Then it did 8.6 E plus O2.
Okay, that makes sense. Interesting. Okay, I'm not exactly sure why it's...
Yeah, because it's not showing any of those extra decimals
Right.
anyway.
So I understand in the case where it was like 858.21, was it, or something you did with...
I did
You just put decimal points after it. Okay. So at any rate, typically if you forget the fix, it would get you supposedly just 2 digits of precision. So I'm not sure why. I'll have to look into why it's printing out the whole thing when...
even just one number after the decimal will allow for the
Okay, so I'll look into that. Okay, so very good. At any rate, you have to make sure you say fixed. In Printf, you're going to see that we don't have to worry about that. You don't have to say fixed. Once you say, so the next thing is the field width. So let's say I say 6. Field width is optional. It doesn't have to be there. Then the next thing is also optional. If it's a floating point number, you may want to specify the number of digits after the decimal point. So this would say 3 digits after decimal point.
Sorry to interrupt you, but I was wrong. It's because I was using constants and it was interpreting it as an integer. If I just put a decimal point, then of course it would be a double constant, and it does what you said.
Okay, very good. I'll still play with it, see what happens, but that makes sense in my thought. Okay. Okay, and then the final thing is a type specifier which says what the type is. Okay, so there are up to 4 pieces of information. There actually can be a little extra, but this is usually it. So this is what it would be for a floating point number. Okay, there are other type specifiers. S says to print a string, you're printing a string. D says you're printing an integer. Then there are, I know I'm getting kind of messy here, so I'll go to another thing. So your type specifiers. So D is an integer. S is a string. F is a float. C is a char. LD is a so-called long integer. It is something where it's declared long. I didn't test this, but normally you have to say LF for a long float, which is a double. Although, again, I did not test this before coming today. It would not surprise me if you can print a float just using F.
Yeah, you can print a double using L.
Yeah, that's what I thought. but usually a long integer has to be printed using LD, so it's a little bit, okay, so we'll just cross that out and say you can also do a double. Okay, now you only use the dot D for a float. For integers, strings, and chars, you're only allowed to give, well, for chars, you shouldn't even be giving a field specifier, really. You might. But for integers and strings, you could often give it a with. You might also give it justification, and then the D or the F. So, for example, percent minus 6s says print a string in a field 6 characters wide and left justify it. Unlike cout, the justification is not persistent. Remember, with cout, once you said left, everything after that was left justified until you changed it. Not true with printf. With printf, you have to, each time you want something left justified, you have to put the minus sign. Also, by default, once you give that with specification and the number of decimal digits, it is in fixed format. You don't have to specify somehow it's in fixed format. It assumes you want fixed format. Okay, so printf is very handy, and I want you to get used to using it. Okay? The advantage of cout automatically is able to determine the type of a variable and print its contents, whereas in printf, you have to tell printf what the type of the variable is. So that's the drawback of printf. Printf, you have to tell it the type of the variable. 1 second. The other thing in printf, if something is not part of a format specifier, it is printed verbatim. So if I say I equals %3d \n, whoops, I, then what happens is I equals gets printed verbatim. Then this is the format specifier, and it will print I in a field 3 characters wide, right justified, and then it will print a new line character so that any subsequent output appears on a new line. So anything that's not part of a format specifier will be printed verbatim to the screen with printf. Okay?
Can you print scientific notation using printf?
The question is, can you print scientific notation using printf? The answer is yes, and since I've never ever done it in my career, I don't know how to do it off the top of my head. I'd have to Google it. Okay. Okay. Alan, I'm not going to get into it because I don't know how to do it. I'd have to Google it, so I'm not going to sit here and flounder with it. The answer is yes. You'll have to look it up. Okay. So if you're an engineer, you'll probably have to do some of that, but my area, research area, is not engineering, so I don't do it. Other questions? Okay, that covers printf. Just quickly, you covered it yesterday, but we will again cover it, which is that there are actually 2 output streams. The output stream that you're used to and an error stream. And cout is the way that you print to a output stream, and error is the way that you print to the error stream. Okay, typically this isn't on output. Both of them are directed to the console, so you don't know what is part of the output stream and what is part of the error stream. But sometimes you actually will do things. I believe yesterday you covered it in lab with redirects. So you might see a command that looks like homework 1 less than, say, input.text, into output. And what this will do is it redirects standard in so that it comes from a file called input.txt. Now, I'll just call it output file to make it clear. Now your output stream gets written to output file, but your error stream will still get written to the console. So any error messages will show up still on the console, but anything written to the output stream will go into the output file. Okay. Now, we haven't yet gone over how using Printf you can write to the error stream. So for the time being, anything you write to Printf is going to the output stream. Okay, there's a way to write to the error stream, but we haven't gone over it yet. So if in lab at this point, if we haven't gotten to it at that point, and we say in lab you need to write to the error stream, use cerr, because that's the only way we've taught you at this point. Okay. For lab 1, I'm fine if you use cout. If you want to use printf, use printf. Okay, either one is fine. Whatever floats your boat. But starting with lab 2, I think I'm going to require you to use printf. Okay. Yes.
Can you print to the standard error using printf?
Yes, not with printf. You have to use something called fprintf.
Is that printf?
Yep.
So I looked it up and it wasn't working.
Yep. You have to use something called fprintf, which stands for file printf, and we haven't talked about that, and I don't want to talk about it yet. So that's why I said printf prints to the output thing. There is a way using a different command called fprintf to print to standard error, but don't. Okay. Last thing, and then we're going to have you do a exercise. And that is, I'm sorry, this took me longer than I expected today, but we're covering 3 sets of notes here. So I expect that pretty much everything in string and vector basics is review for you from 102. Okay? We pretty much covered everything in these notes in 102. So I think you should be able to go back and read it. I'm not interested in repeating it. The one thing that there are 2 things that are we'll even cover that on when we go over top coder on Tuesday. The one thing that is something about vectors occurs at the very end of Dr. Planck's notes, and at the very end, what Dr. Planck is doing, he is got a program, and what he is doing with that program, he's reading in input, and he's putting that input into a vector of, well, actually, we'll go back to this one. He's reading it into a vector. So he's saying, while getLine, he's going to push the strings onto a vector. Okay? Remember, you should have read these notes before you came to class, so I'm not going to spend a lot of time trying to explain this. So you get the line, you push it into a vector, and then once you've read the entire file, he's going to print the last 10 lines in the file. So he's going to subtract 10 from the size of the vector because he's printing the last 10 lines. The next statement takes care of the situation when there's fewer than 10 lines in the file. Okay, so if there's fewer than 10 lines, let's say there was only 5 lines in the file, I would be -5. That's an invalid index, and you would get perhaps a segmentation fault. So if there's fewer than 10 lines, he wants to reset the index to 0. And then finally, he is printing out the last 10 lines. So starting with the value, notice he skipped any initialization here because he had already set up the value of I. Then he's going to the end of the vector, and he's printing out that line. Okay, so that prints the last 10 lines. Now, I want you to read the notes because and I'll probably go over it briefly on Tuesday. This isn't the most efficient way to do it. If you have 1,000,000 lines in the file, it's rather inefficient to read in 1,000,000 lines and store all 1,000,000 lines when you only need the last 10. So there's a trick, which I'll show you Tuesday from these notes, where you can actually hold the size of your vector to 10. Okay, and only ever store 10 lines, which is a lot more space efficient. Okay, but what I want you to look at is there is another way to write the, instead of instead of these last 3 lines, there is a more compact way to write the for loop using these lines. Okay, so you may not yet have seen this way of writing something. So we'll do it. This would come up. There we go. So there is a format where you have condition question mark value or expression colon expression 2. Okay? And what that does is it evaluates the condition. So if I say I less than 0, 0, I plus 5, what happens is it evaluates the condition. If I is less than 0, then the outcome of this expression is 0. Let's say instead I is 15, then the outcome is I plus 5, or 20. So this is a compact way to write an if-then-else, but it returns a value. Normally an if-then-else doesn't return a value. This is a shorthand way in C++ to write an expression that will return a value. So if the condition is true, it returns the value obtained by evaluating expression 1. If it's false, it returns the value obtained by evaluating expression 2. So here, what's happening is it is evaluating the statement is lines.size minus 10 less than 0. So if that is true, if it's a negative number, then it's going to return the value 0. Otherwise, we're going to return the value lines.size minus 10. And this seems to accomplish the same purpose that the previous statements accomplished, which is if I was if after setting I to lines.size minus 10, if I was less than 10, we set it to 0. This seems like it accomplishes the same thing. And while this seems like an awkward way to write it to you now, as you become more experienced programmers, like when Dr. Planck wrote this code, he wrote it like this initially, and it blew up on him. It didn't work. Looks like it should work, and it didn't. Okay? That's why he says something about it being evil. Because it is confusing and evil. Okay? Because it should work. But there's a catch. So if you actually go and try to compile it, if you're lucky enough, you get this handy error message. Warning. Comparison of unsigned expression less than 0 is always false, i.e. it's a tautology. So no matter what happens, that underlined expression it's saying is always going to be false. Okay? And therefore, it's always going to be 0. So in fact, I'm sorry, not 0. The value returned is always going to be lines.size minus 10. So even if we have fewer than 10 lines in the file, we're going to end up with a negative number and our program's going to crash. And the reason it's doing it, it says comparison of unsigned expression less than 0. So we didn't really talk about unsigned numbers in 102. Okay? But an unsigned number is a number that can't be negative. So normally numbers are signed. They can be negative or positive. But you can declare a number like this. You can say unsigned x. And now it declares it to be an integer, but it's unsigned. So it can only be positive. And now it can be any value between 0 and 2 to the 32nd minus 1. Whereas you learned somewhere along the line that with an integer, if you say int x, then it can be any number between 2 to the minus 31st up to 2 to the 31st minus 1. So you had one fewer bits to work with. Ah, thank you. Minus 2 to the minus 31. So if it's a signed number, did I do something else wrong? Pardon? Oh, yeah. Thank you. Yes. 2 to the plus 31 less than x less than 2 to the 31st minus 1. So 1 bit out of 32 went to the signed bit, meaning only 31 bits were available for the number. With an unsigned number, you no longer have the signed bit, so you can get an extra bit for your number, and you can represent numbers, positive numbers that are twice as big. So so an unsigned number is positive, and it so happens that the way C++, come on, give me a cursor. So when I use notebook software, sometimes it eats my mouse cursor for a little while. Annoying. So when you take the size of a vector, that function returns an unsigned integer. Why? Anyone have an idea why it would return an unsigned integer for the size of a vector? There's a good reason. Yes? Excellent. Size of a vector should never be negative, so it returns an unsigned integer to represent that fact. All well and good. However, that has knock-on effects that apparently the C++ developers didn't think about. One of which is that supposedly, so when it does its typing, it says, okay, this is an unsigned quantity. Therefore, when you subtract 10 from it, I'm going to assume it's still an unsigned quantity. May seem silly, but that's its interpretation. So when you subtract a number from an unsigned quantity, it thinks it's still unsigned, meaning it's positive. So when the compiler sees that you're comparing a positive number with 0, it makes an optimization. It says, well, a positive number can never be less than 0, right? That's what's called a tautology. So, well, the inverse of a tautology, Alan. I know you're the logician. So what's the inverse of tautology? Falsology? Contradiction. Thank you. So it's a contradiction. A positive number can never be less than 0. So if the compiler recognizes that as a contradiction, realizes there's no reason to perform that comparison, that the false branch must also always be the branch taken. Therefore, it actually substitutes lines.size minus 10 into the for loop, and it always executes that. And we get the wrong result when the size of the vector is less than 10. Hence the evilness of this little thing. Okay? So just keep that one in the back of your minds. But is there questions about that? I know you haven't seen unsigned before. I know that can seem a little confusing. Yes?
I run into that problem all the time when I usually have to fix it by assigning line size to a number.
So that's exactly what happened up here. That fixed the problem. So your 102 fix. That's why it works up there, because it was assigning it to an integer, and so then it was happy about it. Then it said, oh, somehow it figured out now it's in an integer context, and I'm going to do it as, and not treat it as an unsigned quantity. So, see, this is, you know how sometimes people drive you crazy by being inconsistent? This is C++ applying a different interpretation in two different contexts, okay, and driving you crazy. That's why Dr. Planck called it evil. Okay, yes?
Could you not just add 10 to the other side and say line size is less than 10? It's the same.
You could have, yes. That would have, in fact, been a very nice thing. So Dr. Planck didn't think that way, but that would be a beautiful solution that would take care of it. So this shows you multiple ways of doing it. Okay, it gives you insight into how he thought about the problem. But yes, that would fix it. Very nice solution. Yes.
For the sake of curiosity, could you cast it in that expression?
Could you what? Good question. I don't know. I'm not going to take the time right now to do it, but that's a good question. I bet the answer is yes. That then it would say it's in an integer context, and I bet it would work. But I would have to test it before saying yes to that. But it's working in this context. The reason I say I think the answer is yes is because in this context, it does perform it correctly. So I think that is, if I cast it to an int, it will also do it correctly. So that's my supposition. Mark.
So if you're assigning it to an int or casting to an int, couldn't you have the possibility of having an overflow error? Because if you're going from an unsigned to
Yes,
an assigned,
you could have the possibility of an overflow error, correct. So Mark's point is, if this were a number that was between 2 to the 31st plus 1, and actually just 2 to the 31st, and 2 to the 32nd, it's possible that in subtracting 10, you still have a number bigger than 2 to the, greater than or equal to 2 to the 31st. And a number bigger than 2 to the 31st power cannot be assigned to an int, because an int can only represent a number that is less than 2 to the 31st minus 1. And therefore, this is a dangerous, potentially a dangerous operation, because you could get overflow. The number could be too big and would not fit into I. And then you're going to get an unpredictable result. So it is dangerous. On the other hand, realistically, you're not going to have a file that big. But excellent point. Other questions? Okay, we don't have a lot of time left, but I'm going to start you on an exercise that we will finish up on Tuesday. So it's going to give you some practice with what you did on, we covered on Tuesday. So just give me a moment. And so it's going to give you some practice with, actually this one's going to give you some practice with printf. So just take a moment and write a C++ program, do it with a friend if you want, that reads integers from standard in, sums them, and prints their average to 3 decimal places, and please use printf. Okay, please use printf here. So this is just the start of the problem. We're going to make it more interesting, but we're basically going to be using ultimately vectors, cin.clear, and printf. So just take a couple minutes, write this program. Feel free to do it with a friend. So talk, Ellen and I will circulate if you're having issues. Write it down on a piece of paper if you don't have a laptop and you don't have someone's shoulder to look over. Just a second. I didn't tell you something. This is important for this. If you don't care about the width of the field, just do dot. or XF. So I didn't tell you how wide the field is. So you don't put anything before the dot, because I don't care how wide the field is, I only care about the number of digits after the decimal point. So you start with dot. Oh, sorry. This was meant to represent, so you have to replace, here I'll say NF. This is supposed to represent the number of digits that you want it to print. So you're printing a floating point number, and N is a stand-in for the number of digits you want to print after the decimal point. Okay, if you get this done, this is pretty simple. So if you get this done, move on to step 2, which is to modify your program so that it eliminates bad input, i.e. non-numeric data. That's more interesting. But many of you will.
Should we make it so where it kills on like lines and line characters? Should I just kill them?
Control V. Yes.
How would you kill it?
You can't. Not unless you do some fancy mapping with your keyboard to make it send the ELF character. I don't know how to do that.
Besides just send it ELF character to kill them.
It's Control D. Just hit Control D. That sends the ELF character. That sends the ELF character when a program is running. I saw a hand up. Yes. Oh, I forgot. If with Printf, you have to include C standard. There's another library. You have to include CSTDIO. Hey, remember, if you get it, move on and make it eliminate bad input, non-numeric input. We'll continue it on Tuesday, but start on that if you get through this first part. And then once it sees this type specifier, it knows that's the end of the specifier. And so it then begins, you're going to put this verbatim into like the number of numbers. After the string is what's called the format of the string. So it's the first argument, and then comma, and then so that's the end of the first argument.
What if you wanted to print A, B, C, D, and you do the same thing and you put
Exactly.
so that's
And there would be 3 format specifiers. So if you want to put 3 format specifiers, you got A, B, C, you want to match these.
All right, so we get this.
like if.
Whoops. You all know it. I'm just quickly writing it up myself so I can show you the answer.
Like if while else exit was 0, whatever. I don't think
Okay, so if I could just have your attention, I'm going to go quickly over the solution. If this thing will come back for me. Okay, so just y'all simmer down for a moment. So you have to include C standard IO and IO stream in order. This is my solution. Your solution might differ. In fact, you'll have to change it because this won't work anymore when you have to eliminate bad input. Okay, so just with this, I declared a variable called data. Can someone tell me why I declared sum to be a double? Yes. Excellent. So if I didn't declare sum to be, there's other ways to do this, but somehow I want to make sure that when I do that division at the end that I get a double, a floating point, rather than an integer. And if I declare sum and count to be both ints, and then I do that division, it's going to do integer division on me. Now, there's other ways I could do it. I could declare sum to be an int and then cast it to a double. So I could have done this as well. I could have said, whoops, int sum, and then down here I could have cast it to a double. But there, or I could have used a static cast. I'm showing my age. But I did it like this. Okay. Notice I made sure to initialize the variables to 0. You don't assume they will get initialized to 0. Do that explicitly. Used our little idiom for reading data. And then at the end, notice my printf. I say average equals. That gets copied verbatim into the output. Then %.3f says to print it to 3 decimal digits. And the f says that I'm printing a floating point number. Okay, if I had declared sum to be an int, I would have gotten an integer there, and rather than a floating point. So the f says interpret the result as a floating point number, but it would be too late if I had done my integer division already. Now, on Tuesday we'll pick this up, and you're going to be eliminating bad data that's not an integer, and this while loop's not going to work for you anymore. You're going to have to change the condition for the while loop, because if the data is allowed to be bad, I'll let you go in 1 minute. Can someone tell me what happens to this while loop if the data is bad when I hit my first bad piece of data? It breaks out immediately. So as soon as I hit my first piece of bad data, that while loop will be false, right? And I'll drop out and I'll just print the average of whatever I'd already read. So if I'm going to eliminate bad data and still keep going, okay, then I'm going to have to change that loop condition. So that's going to be the focus of the start of class on Tuesday, is how we handle bad data. And that's also going to give you some insight in how to do Moonglow in Lab 1. If you're having difficulty over the weekend doing Moonglow, then this should give you a little bit of help in that direction. Okay, so I'll see you all on Tuesday, and do get started on the lab. And also remember that if you did not finish the lab yesterday, it is due tomorrow at 11:59 p.m.
Is the submit script working?
Alan, is the submit script working? The submit
It
script,
works.
it works?
Yeah.
Yes, submit script is working.